So in general, this type of question here, data sufficiency, tends to be the more difficult question type for students when they're preparing for the GMAT. Specifically, this type of data sufficiency question, the algebra-related or algebra-related number property type data sufficiency question. In fact, in general, when students bomb the test or they say that they bombed the test and I ask them specifically what caused them the most difficulty, they said, oh, Brian, the algebra just killed me. So as far as my suggestion usually for people before they take the test for real is if they only have like 3, 4, 5 days left before the exam and they ask me, well, what can they do to make a major difference? I usually tell them step up their preparation in this type of question, this algebra-related data sufficiency problem. So with this particular problem here, is the absolute value of x less than 1? My first step is generally to figure out, well, how is it possible that it could be less than 1? So I generally, in data sufficiency, try to always answer the question myself first. So in this case, I say, well, how is it possible? I suppose if x is less than 1 and greater than minus 1, which in other words means, is it a fraction between 1 and minus 1 or 0? That would give me a definite yes. Now, when I look at statement 1, I can see it's all algebra. And my general suggestion when you're doing an algebra-related data sufficiency question is do the algebra. Don't try to avoid the algebra. Quite typically, people try to plug in some numbers, and the problem with that is usually they wind up spending far too long working on the problem and they get nowhere. So my general suggestion is with this type of question, do the algebra first, or at least manipulate the algebra a little bit, try to simplify it in one way or another, and then when you feel like it's as simple as you can get it, at that point, maybe plug in some numbers. But generally, try to evaluate the algebra first. So, in this case, what I have is the absolute value of x plus 1 is equal to 2 times the absolute value of x minus 1. Now, something important, when you're evaluating an absolute value on both sides of the equal sign, you need to square both sides. That's the easiest way to solve such a thing. So in this case, what I do is square this side, which is equal to x squared plus 2x plus 1, which is equal to, when I square this side, 4 times x squared minus 2x plus 1, which equals 4x squared minus 8x plus 4. When I bring everything to one side, normally when you're working with a quadratic, an x squared, you have to set everything equal to 0. So when I bring everything equal to 0, I would get, of course, 3x squared minus 10x plus 3 equals 0. So at that point, what I'm going to do is look for the factorization. So I have 0 is equal to, well, first I'm going to focus on the x squared. I know this times this has to be this. So I'm just going to put in 3x and x, and that equals 3x squared. Then I focus my attention on the 3. This times this has to equal 3. So to be honest, when you have a number higher than 1 here, the easiest thing to do is just come up with any number where the product of the two numbers equals 3. For example, maybe 3 and 1. So now what I have to do is figure out how am I going to get a minus 10x. So to get a minus 10x, I know that I have to look at the inner terms, which is the product of these plus the product of these. How do I know I have to take the sum of these two? Is because this here is a plus. If this is a plus, then the sum of these will equal this. If this is a minus, then the difference of these will equal this. Now, since this is a minus, I know this is going to have to be a minus and this is a minus. So let's just check. Minus 3x and minus 3x is a minus 6x, not a minus 10x. So I know this is not going to work, so I say, okay, let's try something else. And the only thing that comes to mind is, of course, the reverse, which is a 1 here and a 3 here. And I can clearly see I have 3x times 3 is 9x, minus 1 times x is minus x. These added together is a minus 10x. So at that point, I have to solve for x. So basically what I'm saying is 3x minus 1 times x minus 3 equals 0. So if either one of these is 0, then the product is 0. So the easiest thing to do is say 3x minus 1 is equal to 0 and solve for x. That 3x is equal to 1, which means x is equal to 1/3. Or I make this equal to 0, which means x minus 3 equals 0, so x is equal to 3. So according to statement 1, we would know that x is equal to either 1/3 or x is equal to 3. Now the question asks, is x between -1 and 1? So with 1/3, we would get a definite yes. With 3, we get a definite no. And since we're getting a sometimes yes, sometimes no, we say that statement 1 is insufficient to answer the question. So now I have to take a look at statement 2 by itself. So with statement 2, it says the absolute value of x minus 3 is greater than 0. And I think, well, how that's possible? I mean, normally the absolute value of anything is greater than 0 or equal to 0. What we want here is nothing equal to 0. And so therefore, we would know x cannot equal 3. Because if x equals 3, then 0 would equal 0. Anything else would make it bigger than 0. So I know x does not equal 3. But as far as answering this question, it could be sometimes yes, sometimes no. So insufficient. Now when I put both statements together, I would clearly see, since according to statement 2, x does not equal 3, and according to statement 1, x is 1/3 or 3, I would know that x could only equal 1/3, which means the answer to this question is x between here and here. The answer is a definite yes. So we say statement 1 and statement 2 together are sufficient. So therefore the answer is C. Both statements together are needed to answer the question, but neither statement alone is sufficient.